Thanks, Paul. And thanks, Mansi. And thank you to ILSI North America for inviting me to speak. So I work with a company called Creme Global based in Dublin, Ireland. And we're a data science company specializing in, well, one of our areas of expertise is exposure modeling, and in particular dietary intake assessment and dietary exposure modeling. I'm going to talk a bit about the current state of the art of databases and models for exposure assessment, and specifically how they relate to mycotoxin exposure and risk assessment. Okay, so the basic inputs for dietary exposure assessment are quite straightforward. You need to know two things in essence. You need to know the amount of food that people consume, and you need to know the concentration of the mycotoxin in the food consumed. But this question becomes quite complicated very, very quickly due to the intrinsic variability of both of these quantities. So the variability in mycotoxin concentration and how you capture that accurately has been discussed in quite a bit of detail already at this conference. The session on sampling yesterday I thought was absolutely brilliant. I really, really enjoyed it. So I'm not going to dwell too much on that aspect of it, but I will talk a bit about how we capture dietary intake and how much food people eat and how all the different aspects and complications that go with that specific question. So the kind of questions that you would ask for a risk assessment focusing on the dietary exposure component would be these kind of things. So amongst your population of consumers, your total population, what is the mean or average exposure to the mycotoxin? Or what is the upper percentile, or typically what might be, you might call the 95th percentile of exposure in that population? And I will admit there's a bit of a European slant to some of the methodologies and models I'm going to be talking about, but in general this is very universal stuff. Now, already, you may not be concerned with just the total population. You may only be concerned with people who consume a specific food. So, if you take something like pistachios, only a certain fraction of your population consume that food. So, looking at a per capita average in the total population is not very representative of your risk. You've got loads of zeros, a load of people don't eat it. So, you might want to just do your statistics over your food consumers and look at the average in P95 amongst that population. And the key question you want to ask then in light of that is, what is the health-based guidance value for the chemical? What is the tolerable daily intake for the mycotoxin? Or if you're thinking about acute exposure, you might be worried about the acute reference dose. So a schematic of what exposure looks like in a population, you consider all the foods that they eat, all the concentrations of the mycotoxin, you combine them and you get a distribution of exposure, and you see how your tolerable daily intake, you look at where that falls in your distribution of exposure and then make some conclusion on your risk to the population. So how do you do that? How do you calculate exposure? So the fundamental input that you typically use is a national food consumption survey. So these are nationally representative databases of how much foods people consume in your population. You'd usually have to cover over 1,000 consumers in a particular group or demographic that you want to cover. These are very, very large databases and hundreds of thousands of lines of data, and you need to have different subject demographics, so things like ages, genders, body weights, and any other health statuses that may be important for your risk assessment. One of the things you've got to bear in mind with these data sets is that they're typically not developed for chemical risk assessment in the first place. Their focus is on nutrition. So they generally describe foods as eaten, so like composite dishes and so on, not the raw agricultural commodities that you typically have your mycotoxin concentrations in. So you need to convert from one to the other, and I'll talk a bit about how you do that in a sec. So there's loads of different types of dietary surveys, and we have a software application that we've developed called Creme Food Safety that's had to be compatible with all the different types of formats, and it's a massive headache and nightmare. Even in Europe, where people tend to see things as being harmonized, every member state has a different type of dietary survey. So the most common methodology is 24-hour recalls, where each consumer in the survey recalls everything they ate over a 24-hour period, and they can do this for up to 2, 3, 4, 7 days is the biggest I've ever seen. So 7 days of food consumption for every consumer. In the US, for example, you have the National Health and Nutrition Examination Survey, the dietary component of which is called What We Eat in America, and that has 2 24-hour recalls for every consumer in the population. I've also seen 48-hour recalls. In terms of the amount of food consumed, this can be estimated one of two ways. It can be weighed or estimated, so sometimes you have very diligent respondents and they actually weigh using a scale how much food they eat, or else they have an expert dietitian who helps them with that question. And I said these can be raw agricultural commodities or composite dishes. And an alternative approach that you often see are food frequency questionnaires. Now, these are very large, costly studies to carry out. They're only done every couple of years, and they're only ever done really in developed nations. So in developing countries, there's a massive lack of data for this kind of stuff, so it's much harder to do your risk assessment. One of the things they use are things like food balance sheets, which you look at trade, import, export, volume of production per capita in the population. But again, that's a per capita estimate. It really doesn't tell you about your acute risk. The example of the women taking the nuts home and eating them themselves, that would never be captured in a national dietary survey. So the point about these is every survey is different. Every country has their own national diet. The types of foods they eat are different, and the levels of detail varies vastly from one to the other. So in Europe, they had to deal with this. So the European Food Safety Authority have the EFSA comprehensive database where all the different dietary surveys have been harmonized into one system. And they had to convert everything from all the different countries into raw agricultural commodities. So that means you need to know the ingredient fraction for every dish consumed. So this is an example from EFSA's assessment of a divergence from the maximum level for DON and ZON in Europe back in 2014. And you can see for all the foods, they divide them into different food groups. So you've got maize grain for consumption with milling fractions less than 500 microns and milling fractions greater than 500 microns. And depending on those, then they have different ingredient fractions that apply to the different foods as consumed. They use one value across all countries. All right, that's obviously not going to be the case in reality. Every country is going to have different ingredients, different recipes. So this is a bit of variability that's not really well captured. The other thing that you need to think about then, and this has been covered in quite a detail, is your food composition. So you want to know the concentration of the mycotoxin and the level of occurrence. So when I say occurrence, I mean whether it's there or not, and how often does it actually occur. So this is a really important determinant of exposure that's not really taken into account a whole lot, and is something I'm always talking about, needs to be borne in mind. Now, this was dealt with in quite a bit of detail in the sampling session already, but the way you describe concentrations for the purposes of a exposure assessment varies. So you can have point estimates, which are often in a kind of a worst case assessment are assumed to be maximum levels, or you can use empirical distribution, so data from analytical determinations. You can look at known ranges. You can describe them as parametric distributions. So you might know that your concentration distribution follows a log normal distribution with a certain mean and standard deviation. And the point about all of these types of data is that you can use them in a probabilistic or statistical or stochastic model. Okay, so Monte Carlo simulations and probabilistic modeling are the way you capture all of this variability in a risk assessment. All these questions around representativeness, temporality, seasonality, you got to get to grips with this for mycotoxins specifically. It's been dealt with in quite a bit of detail, but again, it's hugely important as an input into your exposure assessment, and how that informs your conclusion on your risk in a population of consumers. Occurrence then is another key driver. And I think a lot more emphasis needs to be placed on this particular input, specifically when you're thinking about aggregate exposure. So the total exposure to a mycotoxin from multiple sources in the diet. If it only occurs in a low percentage of cases, then you need to capture that in your assessment. Otherwise, you're grossly overestimating your risk, and you don't want to do that either. So you can use, if you've got a 7% occurrence of maize in DON, then when somebody eats maize in your dietary survey, you can model that using a 7% probability of exposure. And as you build up your exposure in your population, it tells you a lot more about your average and your distribution and who the high consumers are and what's driving that. And of course, things from your analytical determinations like the level of the detection or the limited detection and quantification need to be borne in mind as well. Okay, so two kind of broad measures of exposure that you consider. Then you look at chronic and acute exposure. So they have very specific toxicological meanings, but they're slightly different in the exposure assessment, and they're always compared. Chronic, as a measure of exposure, is defined to be the average over the survey period for a consumer. So if you have a 7-day survey, which again is the longest I've ever seen, you have a 7-day average for a consumer. So that's how you measure their chronic exposure to the mycotoxin. Acute then just looks at the total exposure on each given day, and they're expressed on an absolute and per unit body weight basis. So how do you do that? Now, everybody is usually terrified of probabilistic modeling. I'm a mathematician. I love it. That's what I built my career on. So I'm going to try and explain how a probabilistic model works, hopefully convince you that they're not so terrifying, and convince you that it's something that people can understand quite readily if you just bear with me for some slides, and I have some very nice pictures that I put together that'll hopefully keep you engaged before you run off for coffee. Okay, so you start with your dietary survey. Again, this is a record of what people ate on a given day over a number of days. So you look at the frequency consumption of the foods of interest that can contain your mycotoxin. You look at the amount of food they consumed in each consumption event, and then you go to your concentration data. So this is usually in the form of statistical distribution. So you do take a random sample from that distribution. Okay, so this is your model of reality. You take a random draw from this, and then because you have the amount consumed and the concentration of the mycotoxin, you can calculate the total daily exposure for that consumer on that day. You repeat that for every other day that that consumer reported, and you repeat that for the next consumer and the next consumer and the next consumer, and you iterate through your survey a number of times. And if you've a probabilistic model that requires a high number of simulations or Monte Carlo simulations, do a large number of iterations, okay, and you build up this picture of exposure in your population. To measure the chronic exposure, you look at the daily average, so you average over the number of days that each consumer reported. To get your acute exposure, you look at just each consumption day separately, okay? And that's how you build up your picture of exposure in the population, using all your raw data. So you never collapse things into distributions if you can avoid it. You use the raw data at all times, because anytime you break things down to summary statistics, there's a loss of information, and you should always avoid that if you can. The effect of looking at chronic versus acute exposure, using the same data, using the exact same data, you're just describing it in a different way, can have a dramatic enough influence on how you profile your exposure, if you like. So the curve on the right-hand side is the acute distribution, which is usually a lot wider because it's prone to more outliers in your exposure. So because it's looking at each consumption event individually. Excuse me, the chronic exposure distribution usually is a bit narrower because you're averaging over the days. So extreme events have less of an impact in your overall distribution. You do that for everybody in your population, and you rank them from smallest to biggest. So you can look at then who's the P95 of exposure. And the point is that's an individual in your population. So that's somebody with a very high exposure, and you usually use that in a lot of regulatory decision making, especially in Europe. In the US, in pesticides, I've seen models go up as high as the P99.9 for regulating pesticides. You look at your median or your average in your population. And that's all it is. The complications around the data sets and how you capture all of that, that's usually where the greatest uncertainty is entered into, not so much in the calculation, I would argue. Now, this question of chronic. I think everybody would agree if you surveyed anybody in the room over 2 days and their entire diet, and you said, right, that's your chronic exposure, that's your exposure for the rest of your life, you'd say, no, definitely not. I'm either not that well behaved or I'm not that badly behaved, depending on the days that you selected. So this is a massive problem in dietary exposure assessment. We don't have very good data over longitudinal intakes, but yet we're always comparing to chronic reference or health-based guidance values. So how do you account for this? There's been a number of modeling type approaches that try to overcome this problem. There's the NCI, or National Cancer Institute model that they developed. Specifically looking at nutrients, there's the Iowa State University model. There's one that my company developed recently for pesticides, which is the CARES-NG model, or stands for Cumulative and Aggregate Risk Evaluation System, next generation. And there's a beta binomial model and a few others. All these models have qualitatively the same effect. Okay, they tend to get rid of these extremes in your distribution again and pinch it in even further. What can happen if you had 2 days of consumption for every consumer, okay? If on those days they just happen to consume a very large amount of cereal, what the model is saying is that for the rest of their lives, they always consume a large amount of cereal. So you're overestimating the risk. What could be worse is that you survey them on 2 days that they happen to not eat any cereal grains, or depending on what you're looking at. So in that case, you've underestimated the risk, and you said they've never consumed it and they never will. And that's the big hole in all of this data. You've only a short number of days for every consumer. So Last thing I'm going to talk about is uncertainty analysis and mitigation, and then people can go for their coffee. Uncertainty analysis is now mandated by the European Food Safety Authority as something you need to include in your dietary exposure assessment. So they have a guidance document back from 2006, and it's all to do with transparency and being upfront about how sure you are about your risk estimates in your population. So they say that every scientific output should describe the types of uncertainties encountered and indicate their relative importance and influence on the assessment outcome. So you know this isn't perfect, so rather than saying it's not perfect, you got to get to grips with how imperfect is it and what is the actual consequence of it, because it may not matter in terms of your conclusion or your risk, or may matter very, very much. EFSA proposed a tiered approach to uncertainty, so looking at different levels of detail. So tier 1 would just be a qualitative analysis, so you just describe them, the different sources of uncertainty and how they impact on your exposure assessment. A tier 2 then would actually be looking at a kind of a quantitative analysis, so you try and quantify it and put numbers on it. Tier 3 would be much more sophisticated. You do a probabilistic evaluation, so you put distributions and you might use a more sophisticated technique like two-dimensional Monte Carlo assessment or something like that. Finally, on the question of mitigation, which is a massive talking point at this conference, and I would just want to say how it relates to the question of exposure. This is a kind of a cycle you might go through when you're looking at exposure and mitigation strategies and how they might influence each other. So starting at the top, you do a particular exposure assessment, and you should follow that. If you are any good a scientist, you would have an uncertainty analysis accompanying it, looking at a qualitative or quantitative assessment of the different sources of uncertainty and its impact on your exposure. You compare then your exposure with your health-based guidance value, and you make some conclusion about the risk in the population. Then, if you're unhappy with the level of the risk, you might look at a mitigation strategy. From the exposure perspective, there are only two things you can do, because there are only two inputs. There's how much people eat, and there's how much the chemical occurs in the food. Really, you don't. In other domains, like for example methyl mercury in fish, there's been guidance around reducing food consumption, but for these broadly consumed foods, that's rarely happened in the mycotoxin arena. So you're really talking about modifying the occurrence and concentration of mycotoxins. If you can quantify this, you can model what the subsequent exposure will be as a result of that reduction. So you can say what your strategy should be and how much you need to quantify it. And you can go through the cycle as many times as you need to until you have an adequate level of risk, or a sufficiently low level of risk established. So to put this in a pictogram, if you had 3 different maximum levels you wanted to experiment with, you could see how that influences your distribution of exposure and how a certain percentile of your population is hitting the tolerable daily intake of the mycotoxin or not. So you can model this and you can quantify it, and you can really say a lot more ahead of time before you introduce the mitigation strategy about what it should be. And I was involved in NILSI Europe expert group on this very question. It was developing a framework or some criteria to assess the effectiveness of dietary exposure mitigation to chemical contaminants. One of the case studies we looked at was done in cereals. And this is the kind of flowchart we came up with. So you conduct a specific risk assessment, and you say, okay, we need to look at certain control measures. You need to then think about the primary and secondary consequences of those control measures. The primary consequence obviously should be a reduction in exposure, but you should be really upfront about how much that is. You know, how is it actually going to make a meaningful impact on risk in human health, and will improve human health. Secondary consequences are also something you need to bear in mind. For example, I think DON can be present in cereals with a higher bran content. Introducing a maximum level might mean that the amount of food on the market or the amount of cereals contain a lower bran content, therefore consumers have a lower dietary fiber in their diets, and that may have its own associated health consequences. So you got to bear those kind of effects in mind as well. Then, having gone through that, you can look at whether your control measures are effective. You also need to consider, are there any other emerging issues since you did your original risk assessment, because if you're working with a committee, this is probably going at a snail's pace, and everything has changed since you started the work in the first place anyway. And finally, then you look at your overall uncertainties and how they influence your final determination of risk. So that was published back in 2014. I encourage you to take a look at that particular paper. And that's everything from me. Thank you for your attention.
Thank you very much for your presentation. It was very nice. 3 questions. I'm going to try to do it first. I think you didn't refer about total diet studies in your method for food consumption. I think this is very important because it's more close to what we eat, because we have to know exactly what is the main meals of the countries, and it's a very good approach. Second, you speak about several models, for instance, in Portugal, and we have bought the at-risk software, and it's not the best, but it helps us. But the problem is it's not specific for exposure assessments, but is the best that we have. And for instance, in European total diet study, exposure study, that is nearly in the end, they are developing a software mainly specific for that. And it's very important that this software has got the possibility to include toxicological data. And this is still difficult, but okay, there are something going on. And for the last question, concerning cumulative risk assessment, we have done some in Portugal concerning infant foods. And what do you use these models you speak about? Well, thank you very much.
Okay, I'll answer in reverse order. So, cumulative risk assessment, yes. I've never done it for mycotoxins. I've spent a lot of time looking at pesticide cumulative exposure from the dietary route. It's a complicated question. You've got the issue of relative potencies and stuff, but there is a mature framework there, particularly in the United States, for how you can do that. So I think pesticides are a good guiding light in terms of cumulative risk assessment. Okay.
Because we have a recent publication on cumulative risk assessment with using at risk.
Okay,
if you find it
good.
Interesting, we can change.
Please do, yeah, send it on. On the question of software and at risk, yes, I completely agree. My company exists because there was a need for software in this area. So we develop custom software applications for dietary exposure that have all of these models built into it. That's why I have a job, luckily. And on the question of total diet studies, yes, absolutely, fair point. I guess They require less modelling, and that's more my area of expertise. But I think total diet studies, sometimes they tend to be, depending on how you composite your samples from the total diet study part of it, they can be more averages of levels of mycotoxins as opposed to peaks, which is more important in terms of exposure. You want to get that at that upper part of your distribution. And I guess sometimes total diet studies don't always capture that information. Yes. Sure.
Yeah.
Thank you. In one of your later slides, you identified 3 possible maximum limits in one of the charts. How do you factor in the practical achievability of each of those options when you're doing such a modeling exercise? Because it's become apparent throughout the conference that that question is emerging more frequently in analyzing the suitability of ML. So where do you do that in your work? How do you apply practical achievability of the MLs?
The short answer is I don't. I leave that to a colleague. But usually it's a discussion between them. So what I can do from my modeling framework, I can say, okay, we want to, for example, we can say, all right, we want our 95th percentile of exposure to be below the tolerable daily intake. I can do a reverse calculation and say what ML would achieve that. Then you can open the question of what's practically achievable. What's practically achievable might be something that only meets you halfway, but then I can say what the health consequences are of that using the exposure model. So it's a kind of a two-way street. I would, again, I'm a mathematical modeler, so I would never be expert in what's practically achievable, but it's something that should be a dialogue between the two as opposed to two exercises in isolation.
Thank you.